In this quick video lesson, we will be talking about the difference between conditional, inconsistent, and identity equations. So first we can define what these are and we'll have a better idea as to what the heck we're looking at in the next couple slides. A conditional equation is an equation with a set number of solutions. So we will be looking at all sorts of equations. Linear equations will generally give you one solution. Quadratic equations will give you two solutions at most. Cubic equations will give you three solutions at most, and so on and so on. So we have a set number of solutions for a conditional equation. An inconsistent equation is an equation with no solution. And that's fine. You probably have run into this in your math career before. But that's how we call an equation that has no solution. We call it inconsistent. And the last type of equation, the identity equation, has infinitely many solutions. And that's it. That's the difference between all three. Let's take a look at some examples and see if we can classify the next equations that you'll see as conditional, inconsistent, or identity. All right, for the first three examples here, we have three equations, and they're all relatively simple to solve. So in this first example, we have 3x plus 7 equals 5x minus 3. And when you learn to solve linear equations, you generally want to move all of the variable terms to one side of the equation and all of the constants to the other side of the equation. So I will do that. I will subtract 3x. That way I end up with a positive number of x's. So these threes over here reduce away. I'll have 2x minus 3 equals 7. All right. Next step is, so we have all of our variable terms on one side. We need to go ahead and get all of the constants on one side. So I will add 3 to both sides. That will reduce away. I will have 2x equal to 10. And then the last step, we can isolate the x, or the variable here, by dividing by 2. And we'll get x equals 5. And here I have an answer. This is x equals 5. There's one answer. It's not infinitely many. It's not no solution. So we would call this here a conditional equation. And I'm referring to this equation back up here at the beginning. The next example, again, following in the steps that we had over here, we want to make sure we get all of the variable terms on one side of the equation first. So I'm going to subtract 2x from both sides, and I will end up reducing that and that. I'm getting negative 5 equals negative 4. And we can stop here. We can stop here and analyze what we have. We have negative 5 equals negative 4. So when all variables, we'll say, drop out of the equation, you want to ask yourself, is whatever is left over is true? Say, is that true? Is negative 5 equal to negative 4? Nope. So this means there is no solution for this particular equation, which means this equation is inconsistent. For the last example down here, we have something that'll be very similar to example 2. We have negative 4 minus 3x equals negative 3x plus 4. So the first thing, again, that we need to do is make sure we move all of the variables to one side of the equation. And again, you'll notice that all of the variables drop out, but this time we're left with 4 equals 4. So is 4 equal to 4? And this time it's yes. So if you get something that is true, 4 is equal to 4, that's true, you have infinitely many solutions. And how we represent that using linear equations, or within linear equations, is this double bar R, or say all real numbers. That means you can pick anything you like. Pick any number. It doesn't have to be pretty. You could pick square root of 2. You could pick 5 over 17, and it does not matter. This equation will always be equal. So why don't we pick that? Why don't we pick 5 minus 3 times, let's pick an x value, what did I say, 5 over 17? Cool. Well, let's see if this checks out. If it checks out, both sides of this equation will become the same number. So let's multiply the 3 times 5 over 17, the negative 3 times 5 over 17. So negative 3 times 5 is negative 15. 1 times 17 is 17. And it'll be the exact same thing over here. We have negative 3 times 5 is negative 15. 1 times 17 is 17. And we have 4 plus a negative equals a negative plus 4. So if I can just rearrange this right side, I don't even have to figure this out. I can just say 4 plus a negative 15 over 17 equals 4 plus a negative 15 over 17. I think that's the same thing on both sides of the equation. So quite literally, you can pick any number and substitute it in for these x's in the original equation, and it'll work out. So we call this type of equation an identity. I want to make it very clear very quickly that you do not have to show that any number works for an identity. All you have to do is just check that if there are only numbers left over, whether it's true or false, and if it's true, you can just say all real numbers and that this equation is an identity. On the next slide, I'll have about 3 more examples. I will be silent so you can pause the video and try them yourself to see if you can classify the equation as conditional, identity, or inconsistent. If you've made it this far and still don't understand what's going on, or maybe you have some work done for these already, I'll go ahead and give you a hint. So here are your hints. Go ahead and try them. All right, hopefully you are getting these answers. Identity for the first equation and inconsistent for the second equation. And really all this means is that it's code for the actual answer here is either this R or all real numbers. And the answer down here for inconsistent is no solution. So let's go through it really quickly. You might notice that these are slightly more difficult with some distribution happening here, but it shouldn't be too bad. So let's see here, 5 times x plus 2 turns into 5x plus 10. We still have minus 2x plus 2 equals 3x plus 12. So then what we can do is we can combine like terms on the right side here. So 5x's minus 2x's gives me 3x's. 10 plus 2 gives me 12. So we have 3x plus 12 equals 3x plus 12. And really, guys, you could stop here. You could absolutely stop here because the entire left side is equal to the entire right side. I like to go down until there's no variable. So I will subtract 3x and say that 12 equals 12. And that I know 100% for a fact to be true. So since I have something that is true, so does 12 equal 12? Yes. So that means our actual answer is all real numbers, and the type of equation this was is an identity. So down here, for example 2, I do something very similar, being that first we distribute all sorts of things. So this would be minus 5x plus 10, because a negative times a negative is a positive. On the right side of this equation, I have 6x plus 2 and 8x minus 32. Now we still have this 19x here and this equal sign here. So it looks like on the right side, we can combine these two things into 14x, and the plus 10, we don't have anything to combine with that. On the right side, I have 6x and 8x combined into 14x, and 2 and negative 32 combine into negative 30. Last step here, I want to move all of the variables to one side or the other. It looks like they all cancel out, and I will be left with 10 equals negative 30. This is not true. That's why our answer is no solution, and this type of equation is inconsistent. So one other quick thing to say about these ideas, identity and inconsistent, or all real numbers and no solution. These ideas pop up over and over and over again when we look at other types of equations, or maybe even inequalities. So an identity, as far as an equation is concerned, could happen with linear equations or quadratic equations or square root equations or any type of equation that you could look at, as well as inconsistent. Inconsistent equations can happen in any situation as well. So just keep that in mind moving forward, that these ideas are not going to disappear. With that being said, go do your homework. Good luck.